Okay, I want to do a quick video on postulates, and diagrams. I think this would be an easier video for you to do, or actually easy section for you to read. But before you read, I wanted to kind of stress the importance of the postulates and the diagrams. We're actually working our way slowly to getting into proofs. Proofs is one of the more difficult things to do in geometry. When people think about geometry, I think outside of the shapes, once they get past the idea that shapes are there, once they get past that, they start thinking about proofs and how they didn't like geometry because of the proofs. So with that being said, it's important that you know these postulates. And just kind of a brief general definition of a postulate. A postulate is something you don't have to prove. Okay, unlike a theorem, which you prove, a postulate is something you don't have to prove. In any case, or a theorem that you try to prove, I guess. We already know 4 postulates. It's probably a good idea to maybe stick these in the back separate from your vocabulary. Maybe stick this in the back of your vocabulary, maybe even make another section in your notebook or somewhere where you stick all the postulates together. But we already know 4 postulates. The first postulate we talked about was the ruler postulate. Basically, that basically says that the distance or the length is measured between one endpoint and another endpoint, and you have your absolute value of distance, basically. So like if you stick a ruler up to something and the front of that is on the 2 and the back of that is on the 6, well, you would subtract 2 minus 6 and the absolute value of negative 4 would be 4, so the distance is 4, or you could do 6 minus 2 and 6 minus 2 would be 4. So that ruler postulate basically just says the distance is between 2 endpoints, the absolute value of the difference between 2 endpoints. Okay, so that's your ruler postulate, and it deals primarily with segments. Okay, then we have the segment addition postulate, another segment postulate, and that basically says the 2 parts equal the whole. Right, so basically you take if you have a segment segment CAT, you take CA and AT, you add those together. So if CA is 4 and AT is 4, then you have a segment of CT, which is 8. So basically you take your segments and add them together to create the whole. So 2 parts equals the big whole. Okay, our next postulate that we already know from our earlier chapter is the protractor postulate, which is, again, basically just like the ruler postulate, except that we're dealing with angles now. So we go back and we take an angle basically, and we say, okay, the absolute value of the difference of 2 rays in an angle is your protractor postulate. Again, that's using your protractor and using your protractor to measure. So where your 2 rays are, the difference between the 2 rays, the absolute value is that distance. Again, that's something that we learned earlier. So if we have something like our ray, generally our ray starts on a 0 or 180, but if we start our first ray on 0 and our second ray is on 60, well, 0 minus 60 is negative 60. The absolute value of that would be a positive 60, or 60 minus 0 is 60, and that would be the protractor postulate in order to find the angle measure. Again, using the protractor postulate to find the angle measure. Okay? Our next one is the angle addition postulate. Again, it's exactly like the segment addition postulate. 2 small angles together to equal 1 big angle. Okay, so that is no different than the segment addition postulate, except now we're dealing with angles only. Okay, so adding 2 small angles, 40 degrees plus 50 degrees equals a right angle 90 degrees. Okay. All right, so let's go ahead and get into our new postulates. Okay, these are all listed on page 96 of your textbook. If you want to go ahead and write those down, you can. Okay, so the first one is postulate number 5. So we have postulate 1, 2, 3, 4, and this is postulate 5. Through any 2 points, there exists exactly 1 line. We talked a little bit about this when we were talking about collinear and coplanar. It's hard to find, because we said that coplanar was any 3 points not on the same line created a plane. Well, a lot of people were confused because they would say, well, those 2 points are on a line, but this one's not. Yes, any 2 points you're going to be able to create 1 line. So that's postulate number 5. Through any 2 points there exists exactly 1 line. Very simple. Point A, point B, you got a line through there. Point A, point C, you got a line through there. Okay? No way around that. Okay? Now, again, postulate 6 says a line contains at least 2 points. Okay? A line contains at least 2 points. So you can't just make a line with 1 point because you don't know which direction. It doesn't have any directionality. It doesn't have any length. It doesn't have any kind of form. So 1 point does not create a line. You have to have at least 2 points. If I take the postulate 5 and postulate 6 and I make an if-then statement, I can say, hey, if there are 2 points, through any 2 points, there is exactly 1 line, then a line contains at least 2 points. Okay, so you can actually make a conditional statement out of those, if you will. Okay, and you can do the converse. A line contains if a line contains 2 points, then the 2 points there exist exactly 1 line. Okay, and then you could actually do a contrapositive and so forth. Okay, so that's pretty simple. A line contains at least 2 points. That's postulate 6. Postulate 7. If 2 lines intersect, then their intersection is exactly 1 point. If 2 lines intersect, then their intersection is exactly 1 point. We talked a little bit about this in a couple of the classes today. When you have 2 intersecting lines that have exactly 1 intersecting point. Okay. Otherwise, okay, because the flip side of this, for some of you in my Algebra 1 class last year, we talked about vertical lines not being functions, because if you do a vertical line test, the vertical line test lays on that function and it hits every single point on that function, which is why it doesn't pass the vertical line test. But the truth is, the vertical line test and the line, the function line or the non-function line, are essentially the same line. So if 2 lines intersect in every point, they're the same line. Okay. So if 2 different lines, basically, or if 2 lines intersect, then their intersection is exactly 1 point. Notice it's 1 point. It's not a ray, not a segment, it's a point. Okay? Our next postulate, postulate number 8, through any 3 non-collinear points, and we've talked about this before, through any 3 non-collinear points, there exists exactly 1 plane. That's basically the definition of a plane. Any 3 non-collinear points. Okay? So through any 3 non-collinear points, there exists exactly 1 plane. We talked a lot about this when we talked about the stool or the table. You know, how the stool has 3 legs that are in 1 plane and the 4th leg is off. Okay? We're not going to get into that anymore. You guys probably remember me putting the table up on the stool up on the desk. Okay? Postulate 9. A plane contains at least 3 non-collinear points. You should start to see a pattern developing. Here, we defined a line. Okay, 2 points create a line. Here, a line has at least 2 points. These are conditional type statements. Here, we define, that's completely different. So here we define the plane. And now we're saying, hey, a plane has to have at least 3 non-collinear points. You don't have a choice. It must have those. That must be a condition it meets in order to be a plane. Okay? Postulate number 10. If 2 points lie in a plane, then the line containing them also lies in the plane. Okay? So there are times there was an example on the test that showed a line intersecting a plane at one point, that point B. But in this particular case, this entire line, if an entire line is on the plane, it can be contained on a plane. So if 2 points lie in a plane, and any 2 points can create a line, then that line that's created, that's within that plane, is also lying on the plane. Okay? And then finally, our last of the new is postulate number 11. It says if 2 planes intersect, their intersection is a line. Okay? And that's important because we were having a hard time, I think, on our test understanding that, hey, when 2 lines intersect, it's a point. If 2 planes intersect, it's a line now. Okay? That's what they do. They intersect at points and lines. If a plane and a line intersect, that's a point as well. Okay? Or it's an entire line. So, what are you going to do with this stuff tonight? On your homework tonight, it should be very simple. Okay? You're basically going to look at diagrams like this and tell me what this postulate is. So read this. Eventually, at the end of the year, you'll be able to write these postulates without using any words at all. So let's look here. What does this say? If, what does this represent? Okay? If 2 lines intersect, then their intersection is exactly 1 point. So here's the 2 intersecting lines. Here's the exactly 1 point. So that's postulate number 7. Let's look at this one. What do we have here? We have 2 planes, and remember a plane goes on forever. We draw a plane in this rectangular pattern to give it, or this rhombus pattern, or whatever you want to call it, in order to give it its dimensionality, its 2 dimensions. But a plane can exist forever. So this is an example of a plane. So if 2 planes intersect, so here's 2 planes intersecting, then, okay, so if 2 planes intersect, then their intersection point is a line. That's postulate number 11. Okay, let's look at this one. If 3 points are non-collinear, like these 3 points, then these 3 points create a plane. Plane ABC there. That's postulate number 9. I'm sorry, postulate number 8. Through any 3 non-collinear points, there lies exactly 1 plane. Okay, the next one. If you have a plane, then you have 3 non-collinear points. So this is the reverse of this. Okay, that's postulate 9. If you have a plane, then you have 3 non-collinear points. All right, so let's look at this here. We're going to look at this diagram and we're going to ask the question, can you assume? Can you assume that G, F, and E are collinear? Can you assume that G, F, and E are collinear? The answer would be no, you cannot assume that because there's no line drawn through them. Can you assume that G and F are collinear? Absolutely, because you can assume based on postulate 5 or 6, a line contains at least 2 points, or through any 2 points it glides exactly 1 line. So G and F are linear, are collinear, but you cannot assume that G, F, and E are collinear without the line drawn. You can only take what you see on the picture to make your assumptions. Okay, can you assume that all points are coplanar? Well, let's take a look. Are all the points lie within this plane? We draw this plane in order to kind of give us a guideline. Are all the points in that plane? Absolutely. So you can assume that. Okay? Can you assume that line, and it says segment, but I want to say line, BF and CE intersect? Can you assume that BF and CE intersect? And again, assume those are lines. No, you cannot assume they intersect. Okay? The reality is until we go back to our algebra roots, until we find out the slopes are the same or the slopes are different, we can't assume that they intersect at all. At the same time, the next question says, can you assume that BF and CE do not intersect? No, you cannot. Without the algebraic knowledge of slope, you cannot assume that they're intersecting or not intersecting. So the answer is no, you cannot assume either one. Okay? Can you assume that angle AHB and BHD are a linear pair? Yeah, you absolutely can. AD through any 2 points is a line. AD are 2 points that create a line. They happen to be made up by AHB and BHD. So that's absolutely true. Okay? How about this? Can you assume that AHF and BHD are vertical angles? AHF and BHD. Yeah. Do they share the same vertex? Then they're vertical angles right there. Okay. Can you assume that BHA is congruent to CJA? Okay. At this point, what you know with geometry, you cannot make that assumption. Okay. When we get into transversals and parallel lines, you will be able to determine if that is true or not. Okay. Can you assume that AHJD are collinear? You absolutely can, because they're all on the same line. You can see that clearly. AD creates a line, they all are on that line. And then finally, can you assume that AHB is 90 degrees? No, you cannot. There is no right angle there to tell us that it's 90 degrees. Okay. All right, so your homework tonight is going to be a lot of identifying postulates and identifying things, proving postulates based on a diagram. So it should be relatively easy. Please come in tomorrow to tutoring or during class. We're going to have more class discussion on some stuff tomorrow. If you have any questions, please let me know. Have a great and wonderful evening. Make sure you get caught up and read Blackboard. Here's your homework for tonight.